Hi, this is your instructor, Ryan Chatterson, and this week we'll be discussing Aquaponics 101. Now, this is for all of our beginners and our people that don't have much or any experience in the aquaponics field. This is to basically get an explanation going and get you started. From there, we'll get into the real meat of the course. So let's start with what is aquaponics. Aquaponics is the integration of hydroponic plant culture and aquaculture. Fish-produced waste, which is sent through a filtration system that renders that fish waste into an acceptable hydroponic fertilizer for plants and vegetables. The plant and fish system can be coupled, which is recirculating, so from the from the fish to the plants, then back to the fish, or that system can be decoupled. So both of those systems, the fish system and the plant system, are running independently of one another, and depending on a variety of factors. You'll see aquaponics abbreviated throughout this course as AP. The nitrogen cycle. So fish excrete ammonia as a main waste byproduct through their gills and in their feces. So as they're breathing in oxygen, they're actually excreting ammonia out of their gills. Naturally occurring nitrifying bacteria, Nitrosomonas, Nitrobacter, Nitrospira, Nitrosococcus, Nitrosolobus, Nitrosovibrio, etc., convert ammonia from its toxic form, NH4, into nitrite, which is the middle step here, which is less toxic, and then finally to nitrate, which is NO3. Now, though all of these nitrifying bacteria are occurring naturally in our system, the main two we will be focusing on throughout this discussion in this course are Nitrosomonas and Nitrobacter. Nitrate is not toxic to fish unless in very high levels and is the preferred form of nitrogen for plants to uptake. So why aquaponics? Well, it's very resource efficient. We can grow the same crops in an aquaponics system using only 5 to 10% of the water that it would take us to grow that as a normal terrestrial crop, meaning in the ground. We have dual income streams. So we have an income stream coming in from the plants, whether it's vegetables, ornamental plants, flowers, etc. But then we also have an income stream coming in from the sale of the fish. Now, in a hydroponic operation, we buy fertilizer and we sell plants, but we don't get any return from buying fertilizer. In an aquaculture operation, we buy fish feed and we grow fish and sell fish, but we don't get any return from the fish feed unless you're selling the fish waste to a farmer, but not all aquaculture operations do that. But in aquaponics, we are combining these. So instead of having a fish waste stream that we have to build a wetland to negate or something of that nature, or having a hydroponic waste stream maybe of high saline water that's left over from water exchanges, we couple these and we're able to have little to zero waste stream coming out of both of these technologies. And again, we're getting a dual income stream out of that. We have an ability to grow an extremely wide variety of vegetables. Personally, I've grown over 500 varieties of vegetables in aquaponics, specifically in aquaponics and deep water culture systems of aquaponics. So I can tell you firsthand, this isn't just a rumor, it's not just some thing you've heard out there. I've personally done it, so I can tell you, we have the ability to grow just about anything you can imagine, in any color you can imagine. We just have to recreate the environment that that particular species is going to want to grow for, at its best. We can produce extremely high quality food. So in an aquaponics system, we can produce an extremely high quality, nutrient dense, high brix food by using this technology. If we couldn't do that, then we wouldn't be growing using aquaponics. We wouldn't use a technology that grows something inferior to what we can grow in the ground. So it's a superior technology. And we can do this in any environment. We could do this Right here in Florida where I'm at, we can do this in Alaska, we could do this in Antarctica, we could do this in Africa, we could do this up on a mountain. You know, take your pick. If you can recreate the environment, if it's somewhere that's not, you know, doesn't have the specific requirements that the plants you're growing need, of course you need a structure, a greenhouse, something of that nature. But if we recreate that environment, we can do this anywhere. The technology transfers anywhere, and that's very important. So aquaponics mimics nature. You have to think of a lake ecosystem. In that lake, insects, which are a protein source, are going to land on the surface of the water and get eaten by fish. Small fish feed on those and algae, which grows off of fish waste. Larger fish are going to eat the smaller fish, etc., all the way up the food chain. Fish excrete waste. The bacteria in the lake converts that waste, just like in aquaponics. Plants such as submerged grasses, lake reeds, lily pads, cattails, you know, any plants you see around a lake take in the dissolved nutrients and they thrive around the lake. And that's submerged plants or terrestrial plants. We have simply engineered this system to grow edible plants and fish. It's as simple as that. It's the same thing occurring. Instead of insects as a protein source, we're adding feed. That's the protein source. The same mechanisms are occurring here, but we're controlling each mechanism at each process point, and we're controlling what we grow at the end. So it's very natural, even though we're engineering the system ourselves. And I'll leave it with that. Any questions, email me, and during the next session, we're going to really start getting into the aquaculture design phase, which is the battery. It's what runs the entire aquaponic operation. So a lot of important facts, details, and formulas, and I'll see you during that session.